Let's start with the Caesar cipher class. I started by creating the encrypt and decrypt methods. The encrypt method uses this main piece of code to encrypt the text. In Java, every letter is stored as a number, its Unicode or ASCII code. We subtract the Unicode for each letter to get the actual placement of the letter in the alphabet starting from 0. For example, A's Unicode is 65 and B's is 66. Subtracting them gives us 1, which is B's place in the alphabet starting from 0. Then we add or subtract the key depending on if we want to go left or right in the alphabet. We add 25 to keep the number positive. To keep the number between 0 and 26 and wrap around the alphabet, we get the remainder after dividing by 26. Finally, we add A back to turn the 0 to 25 index into a Unicode to turn into a char. Lowercase letters and uppercase letters have different Unicodes, which is why this is necessary. For decrypt, the same is done but with a negative version of the key. The constructor contains the GUI for this class. I made sure that the decryption can be done to the text in the text field as well as the text that the user inputs, which makes it easier for testing. Now on to Cipher Cracker. The constructor allows users to input encrypted text manually or load it from a file. When they click the Crack Cipher button, the Crack Cipher runs through all possible shift values from 1 to 25. For each shift, it decodes the text using the decode shift method, which shifts letters backwards. The score text method gives a numerical score to the string by counting how many words are in it. If a decoded message has a lot of real words, it's more likely to be the correct decryption. If it's just gibberish, it might have fewer recognizable words. The best results, meaning the decoded version with the highest score, is then displayed in the output area along with the shift value used and the score it receives. Class, it takes the data from previous user input and formats it into language.txt so it can be compared to text that language needs to be detected. The data that is taken is how many times words are repeated in a given text, average number of words per sentence, average length of words, trigrams, which are 3-character sequences, bigrams, which are pairs of consecutive words, and frequencies of each alphabetical letter. For frequency bigrams and trigrams, cosine similarity is used. In our context, cosine similarity measures the shape or pattern of the distribution, ignoring scale differences. For example, suppose language profile A has 1,000 total letters and 200 of them are E's, 20%. And language profile B has 10,000 total letters and 2,000 of them are E's, also 20%. Even though B has way more E's in the absolute terms, 2,000 versus 200, the proportion of E's is the same, 20%. Cosine similarity compares vectors as directions, not lengths, so it focuses on these relative proportions, meaning A and B are likely the same language. The math of this is what we did in advanced functions. It measures the angle between two values using dot product over magnitude formulas to check if the vector is pointing in the same direction. For the rest of the information, it gives the average of the new data compared to the old data. The score after comparing the data in text file in language.txt gives us the best language that the user inputted text can be. This is what language.txt looks like. This first part is the frequency of each character. Then this number represents other statistics, such as average character and sentence length, with the name of the language at the end. The language profile class is important because it keeps all the key information about a piece of text, like character frequencies, common word patterns, sentence lengths, and more, in one organized place. Instead of managing separate variables for each feature, this class groups them together into a single object, making the code cleaner, easier to work with, and more efficient. Lastly, we have the GUI class for detection. It lets the user choose between picking a file or type text for detection. It saves the data from the text and compares it to information in language.txt. If it doesn't know the language, it says unknown. Then it asks the user if the language is correct to expand its database. It adds information from the provided text whether or not it's correct. However, if it's incorrect, it asks for the correct language. Lastly, we have the main class, which calls the main GUI class, which contains all of the other classes.
Hello, my name is Walter McLean, and this is our language, our basic language project model application, and so on. So today this will be a tutorial video on how to go through our application, go through all these tabs and how it works, and yeah. So first we'll start with the trainer tab. With the trainer tab, with the trainer tab it returns it with the trainer tab and then training.gui it returns a JPanel. This JPanel, which has article here, this panel basically allows the user to specify which frequency threshold they want, as you can see here, as well as a file they want to choose to clean. This is backed up by the code in trainer, which for example in train.build model allows us to read each line, and the language model allows for allows us for the language model add line down here allows us to tokenize and counts all the letters only token, and the filter stop words filters the stop words, and the remove rare words removes all the words which is basically below the frequency threshold. And we have the map here. We also have the recording, which will basically try to keep track of everything inside here, which will be utilized by this class, which will is basically our frequency model. So it will once we do release 15, for example, once we take a storage, we can just take a random file, let's take Spanish, and this will after we press open, it will clean the file and basically output a clean text in the storage file here. And yeah, and the message and the status of the message will be appear here in the console just for exist. It will show you exactly where it's producing and which threshold it had. For let's do this one, boom, it will have the whole entire clean file here, and etc. In our like previous in our previous version of the program, which is still our current version, but this one it has a clean text files, but with the clean text files, it will also have the top words for each, the top words, which the basically the highest frequency words for each program. And here, it allows us to just note down on which words are very relevant, and it's all best for data management. So moving on, we have the tutorial tab as well. So when I have the tutorial tab, it gives a simple tutorial here. For example, use the tell that to guess the language, the cracker tool to decrypt unknown Caesar encoded messages, and you can return here for any time. Once we press this, but currently we do not have the video inputted in in this section here due to the fact we are in the video currently. So afterwards, after the tutorial, you will see the tutorial video in here. But since we don't have the video right now, it will say video file not found or kind of open, and this is where we're able to input the video. Currently, we will have it just by reading the tutorial file. If there are any problems coming, we will just have a YouTube link which will be accessed from here as well. So we also want to go over the Firebase. So we're unable to directly link the output straight to the Firebase, but we were able to initialize the Firebase here. For example, Firebase language was this holds all the cleaned languages, all the clean version of the languages. For example, English language, it removes all the numbers, any weird symbols, and just pure just English text. We also have it for French. A lot of French here. All the pure French text, all the numbers and symbols are completely clean, and Spanish language, same thing here. With the clean text, no, with the clean text, we could continue have if we're able to use another, I guess, another app, or you can find another alternative for a database. We will we will do it in cleaning service. So cleaning service or the trainer is where the main content of the output and straight to a database will go. The service basically allows us to take the files for from somewhere. It will output the message after it cleans it, and yeah, the uploaded text will hopefully the uploaded text will hopefully just go will be output straight to the Firebase afterwards. This is the main code allows us to which allows us to have the clean text. This can definitely be adjusted to immediately output the Firebase after it's finished. So yeah, this is our program. The other features will be given by my partner, Manit.